Welcome to the revision class for work, power and energy. Uh, this is for Olevels and IGCE students. So first we will discuss work, okay? Then we will be discussing energy, and after that we will be discussing power. These three quantities are basically interrelated with each other. For example, let's discuss work first. In physics, a work is said to be done when an unbalanced force is acted upon an object and this object is displaced, it changes its position. For example, there is an object, an unbalanced force is acting on this object, and when this unbalanced force is acting on this object is displaced, it covers some distance. When it covers some distance, we said that work is done. The formula for work will be W is equal to F multiplied by T. Now we can also work out the unit for work, that will be Newton from the force and meter from the distance. So it will be Newton meter. Collectively the unit will be joules. Work is dependent on these two quantities. If any one of them is not there, work is not done. Second thing is, why I call it an unbalanced force. This is a very important concept in physics. Why I'm not calling it just a force or a balanced force. So, for example, we have an object. Maximum inertial value for this object is maybe like 10 Newton. When a 2 Newton force acts on it, with respect to the Newton's laws, we will say that the inertial force will also be 2 Newton. Both of the forces will be balanced. Up till 10 Newton, the force will be balanced with the inertial force of the object. I'm talking about Newton's first law. But as the force is increased to 11 Newton, this object will not be able to balance this force. So this 1 Newton extra force will be utilized to do work. Now I am assuming that the concept for work is clear. Now we will be moving towards the concept of energy. Now there are many forms of energy. Mostly discussed in our book was kinetic energy and potential energy. Energy is defined as the ability to do work. Energy is defined as the ability to do work. Now there are many different energies, but mostly discussed are kinetic energy and potential energy. Now for kinetic energy, the formula is half mv square. And for potential energy, the formula is mg delta h. Why I am not writing only h? Because this delta, it basically shows the change. For example, an object is at a height of 1 meter and it is moved for 2 meters to get a height of 3 meters. Now if you want to calculate the height obviously will be 3 minus 1, that will be the 2 meter height. So that is why we are calling it delta H, because we need the change in the position. Okay. Now, there is a concept that is known as the principle of conservation of energy. Now, what this principle say? This principle say that energy can neither be created nor be destroyed, but can convert into one form to another. For example, we have a pendulum. This pendulum is oscillating with respect to its mean position. When it is reaching the maximum height here, the potential energy will be maximum, while the kinetic energy will be minimum. Same will happen with this height because it is also can be regarded as the maximum height. But here at the center, there will be the minimum potential energy. The kinetic energy will be maximum when it is still in motion. Kinetic energy is basically dependent on motion. You see this V. For example, this V is 0. So basically there will be no kinetic energy because anything multiplies by 0 is basically 0. So this is the concept of interconversion of energy. We can see interconversions in many ways. For example, if we take an example of a thermal power plant, so the heat energy is being converted into the mechanical energy, and this mechanical energy is converted into the electrical energy through generators. So there are many examples in this regard for the interconversion of energy. Now, what is the relation of energy and work? As energy is the ability to do work, but all the energy is not converted into work. For example, we have supplied a system energy of like 12 joules. This 12 from this 12 joule, only 3 joules of work is done. Only 3 joules of work is done. So this 12 joule will be now 12 minus 8, 9 joules. So 9 joules of energy is left and 3 joules is utilized to do work. We can also refer work as delta E, the change in energy, because 12 minus 9 will be 3. So work can also be referred as delta, the energy that is utilized to do some work. Now we move towards power. For power, it is very definite that it is dependent on two factors. First one is work and second one is this change of energy. For power, we have power will be equal to, for power, we have a formula, the rate of doing work. In physics, when we are considering a rate, sorry, we are considering is as per second or divided by time. We can also say that power is equal to the change in energy upon time, or the energy transferred upon time. We can refer delta E as energy transferred also. So this will also be per second. That how much work is done per second. We can derive the unit for power, basic unit for power is watts, and watt is basically equal to what is the unit for energy, that is Newton meter, or work, that is also Newton meter, that is joules divided by seconds. So joules per second is watts. Okay. Now we have not discussed the unit joule for energy. Now we will be driving the unit for energy. The unit for work is joules, and for the unit of energy is also joules, but we will see that how this joules is actually coming in this scenario. And for the power, we've already done it is watts. So for energy, what we have, let's take the formula for kinetic energy, that is half mv square. So this half is basically constant. Okay, so obviously we are not considering it, we are considering it mv square. For v square it will be meter square and meter per second, because so it will be meter square and time squares. For mass it will be w is equal to mg, m will be equal to w upon g, that will obviously be Newton upon meter per second square. This is in the denominator, it will move upwards. So we can also call it time square with respect to this. So it will go up, it will be Newton time square upon meters. Now this we will put here Newton t square upon m. T square is cancelled, and one power of meter is gone. So Newton meter, that is joules. Now let's take an example of potential energy. In potential energy, we also have M, G, and delta H. Delta H is basically meters, mass and gravitational force. So it will be Newton upon meter per second square, and it meter per second square, and it will also be meter per second square. So this meter per second square and meter per second square is cancelled, and Newton meter is joules. Hope you guys have enjoyed and understood the lecture and the basic concepts. This is Syed Haider, and I'll see you next time.